everyone, it's Med Cosmos here. Today, we'll explore the micturition reflex in the cosmos of medicine. Micturition reflex results in voiding of urine. Before getting into the reflex, we need to know a little bit of anatomy here. This thickened muscle that you see here is called the detrusor muscle. It is an involuntary muscle. This muscle is called as the internal urethral sphincter. It is also involuntary in nature, whereas this muscle is called as the external urethral sphincter. It is voluntary in nature. This micturition reflex is a parasympathetic reflex. The parasympathetic centers are S2, S3, and S4. These are the afferent nerve fibers that innervate the detrusor muscle as well as the internal urethral sphincter. This causes the contraction of the detrusor muscle and the relaxation of the internal urethral sphincter. As a result, the urine in the bladder is pushed into the urethra. On the other hand, we have the sympathetic system. The centers are L1 and L2. Here, they travel through the afferent fibers. They also relay in a hypogastric ganglion. This is the hypogastric ganglion. And then innervate the detrusor muscle as well as the internal urethral sphincter. Here, it causes relaxation of detrusor muscle and contraction of internal urethral sphincter, so the urine doesn't go out into the urethra. External urethral sphincter is under the control of the cortex. Coming up to the reflex components, I like to describe a reflex under these 5 headings. The stimulus, which is here the stretch of the bladder, the afferent, center, and the efferent, as already discussed, are a part of the parasympathetic reflex. Remember that the parasympathetic fibers traverse through the pelvic nerve, both the afferents as well as the efferents. Finally, the effect is micturition, also in simple terms, the voiding of urine. Now, this is a very simple flow chart that we can follow regarding the voiding or the emptying phase. As we can see here, the filling causes the stimulation of the stretch receptors. Next, we have the afferent impulses going through the sacral segments, then from there sent to the efferent nerve, which causes the main important thing, contraction of the detrusor muscle. So earlier it was like this, and now it becomes smaller because of the contraction, and also it is opened because of the relaxation of the internal sphincter. This causes the flow of urine into the urethra. Also, here comes the external sphincter. Now, the external sphincter is actually innervated by the pudendal nerve, which is under the direct control of the cortex. So whenever there is activation of the cortex inhibits the pudendal nerve, causes relaxation of external sphincter, finally leading to the voiding of urine. We have higher control centers. 3 main higher control centers are the cortex, the midbrain, and the pons. As earlier stated, the cortex is very important in the continuous contraction of the external urethral sphincter. In simple ways, it maintains the tone of the external urethral sphincter. The midbrain, it has storage center. That means it inhibits micturition, whereas the pons has a pontine micturition center. That is, it supports the voiding of urine. Another important and very fun thing to know is that the cortex will not be able to do this at less than 3 years of age, and that is the reason we see bedwetting in children. Now, the diagram you can see here is the cystometrogram, and the procedure that has been used to obtain it is cystometry. So this is the procedure, don't get confused with the terms, and this is the recording as I've put a picture down. Now, we need to understand that this recording is based on Laplace law, which states that the pressure inside a spherical viscous is equal to twice the tension upon the radius of the spherical viscous. Now let's divide this thing into segments. Coming to the AB segment, here the pressure is directly proportional to tension. As a result, as the tension increases due to the filling of the bladder, the pressure also increases, as seen here. In segment BC, which is a plateau, as you can see, it is because of a property of the bladder called as plasticity. Now, plasticity is the property of an object to change its radius as per the tension. So here, at segment BC, as the pressure keeps increasing, the tension increases, which is a well-known fact. However, the radius also tends to increase, and because the pressure is inversely proportional to the radius, it cancels out. Therefore, the pressure remains perfectly constant. That is the reason for the plateau on the cystometrogram. Finally, at segment CD, we can see a steep rise because there is no more compensatory radius increase that we can see here. As a result, the pressure directly increases with tension and leads to voiding. Coming up to the applied aspects, wherein the name of the particular dysfunction helps us to know a lot about the underlying pathophysiology. So here, the name of this dysfunction is atonic bladder. Atonic means no tone. That means the sensory fibers here have been disrupted and they are not able to deliver the tone to the sacral spinal centers, which are the parasympathetic centers. Now, there is no information of the tone that goes to the sacral centers. Therefore, the bladder becomes hypotonic and flaccid. It has no tone whatsoever. As a result of this, we see what is called as overflow incontinence. So the urine just keeps on filling, and once there is no more place left out, it just overflows. Therefore, the term is called as overflow incontinence. Sometimes it is also called as overflow dribbling. The next applied aspect is called the uninhibited neurogenic bladder. Now the name says it all, always. Uninhibited, that means there's a lesion in an inhibitory center. So we know that the inhibitory center here is our midbrain, as shown. Now, this midbrain has a lesion in it, as a result of which it has to normally inhibit it, but now it's not able to do so. Therefore, the urinary bladder, it just acts out. So, it is called as spastic, being spastic in nature. Now, this results in whatever small amount of urine that has accumulated to just come out. Remember, this is not because of overflow. It is because of overactivity of the bladder, as it is not under higher controls. So that's it for today's lecture. Thanks for watching. Please like, share and subscribe for more. It's MedCosmos here. Bye.